In last week's tutorial, I talked about how to move resources between planets, and in the process I mentioned that you can set up communication systems to ensure that you don't end up with too much being sent. I don't think I went into enough detail with the setup, however, so this week I'm going to talk about the communication side in a bit more detail. Welcome to Laurence Plays Factorio Space Exploration. Here we have a delivery cannon. These massive railguns can send a delivery cannon capsule with a stack of a certain resource to any other planet in the solar system almost instantaneously. However, you do need to build up the capsules first. They are rather limited in the resources they can send, however, essentially only allowing ores and raw resources such as iron, copper, holmium and various barrels. Pretty much the only exceptions to that are glass, explosives and scrap. I've given this one a belt of iron to pull from and placed a delivery cannon chest off to the side over here. Normally you'd fire these at a different planet, but this sort of distance will work quite nicely for the demonstration. So, the first thing I'm going to do is program the delivery cannon. I want it to send iron plates, here we go, and I want them to go to Norvis, and I want them to land here. Now, as you can see, the cannon has started picking up iron plates, and it's turned those into a delivery cannon that is ready to fire. So now I can turn the system on, and it'll fire, and it will start to deliver the iron plates as fast as the inserter can load them. The receiver chest over here will slowly fill up as the plates arrive, and so these can now be taken out to be used by the outpost. The problem with this setup is that the delivery cannon doesn't know how full the receiver chest is, so it will never stop firing. This means that eventually the delivery cannon chest will fill up, and the capsules will start to crash land, causing damage to absolutely anything in the area, and scattering some of that resource on the ground. Like this. So, now we need to tell the delivery cannon when to stop. So, I'll start by turning it off manually, and then clearing up the mess. There we go, all back to normal now. This is all about communications, as I said, so we'll put in a transmitter, and a receiver, and these would obviously be on the planets with the where the delivery cannon and the delivery cannon chest are. These buildings need to be given a channel name to communicate on, which means you can have as many separate signalling systems as you want. I should call these ones demo because that's what this is. Make sure you get the capitalization correct on the same, because it does care about that. And the transmitter can now be connected directly with a red cable or with a green cable directly to the chest, like so. This means that this will now be sending the signal over to here. But just to make it a bit more obvious, I shall also connect in some pylons to both of these systems, so you can see. So we can now have a look at the signals that are being carried around. So at the other end, we'll connect the receiver to the pylon, like so. And as you can see, if we mouse over that, we see 4,000 iron plates on it. So now we need to somehow connect this delivery cannon to the cable. Unfortunately, if I connect the cable, I can't connect it to directly to the delivery cannon. So what I'll do instead is hook it up to this inserter down here. And this is the one that, as you can see, is inserting the iron plates into the delivery cannon. And that means it's trivial to now program the inserter to only work when there's fewer than 2,000 iron plates on the network. So at the moment we're seeing 4,000 plates, so the inserter is turned off, as you can tell by the little red light on the side of it there. This will keep the delivery cannon chest at a suitable level and able to supply its part of the factory, but without overflowing. Do note that when the signal drops below 2,000 from here, you might end up with slightly more being sent over than you would expect, because it won't stop firing until the signal gets sent back round, and then anything inside the buffer inside the delivery cannon gets used up. So if I come over here and I take out some of the iron, so if I take out enough of the iron plates to drop this below 2,000 again, I can turn the delivery cannon back on, and it will start firing again. Now we've got exactly 2,000, and it stopped because we've got 2,000 in there. So the inserter is now turned off again, so the delivery cannon has stopped working. If I take out another couple of stacks of plates, again you can see the inserter immediately starts loading up the cannon, and once it's got enough iron in it, the cannon will fire again, delivers over to the delivery cannon chest, and it keeps firing until it's full. Perfect. As you can see, this works very nicely, but there is one major problem with the system. If you have a power cut at the transmitter end, perhaps due to insufficient solar power on your outpost, the transmitter stops transmitting, meaning that the inserter will see 0 iron plates on the network, and it will start firing again. Just what you need. As well as a power cut, you've now got iron plates falling from the sky and starting to damage things. Fortunately, there's a neat fix for this. let's put the power back in, and then we'll put in a constant combinator next to all of this setup, and we'll link that in as well. We can now set this to the negative of what we want to see. So in here we put minus 2000, and then over here we tell this to only insert when there's less than 0. So when there's a negative number being seen. So with this setup, the circuit network automatically adds up the number of plates that are in the chest, 2400 in this case, and the number that's coming out of the combinator, minus 2000, and we get 400. If we look over here, we'll see exactly the same at this side. Because that is greater than 0, this inserter stops working. So if we go in here again and take out another 600 of these iron plates, again the inserter immediately starts working because the number on the network has gone to minus 200. However, if you do get a power cut, the number on the network falls to 0, which is obviously not less than 0, and so the system then stops. Yes, okay, sometimes there's a little bit of lag in there because it's already halfway through trying to make the next delivery cannon capsule, but you'll only get one extra one being fired over. Next, we're going to go and take a look at something very similar with rockets, but first, please make sure you're subscribed to the channel so you don't miss any of the future tutorial videos. So, up here I've connected my rocket landing pad to a combinator and to a transmitter. The transmitter sends its signal to the receiver over here by the rocket silo, and from here we have a number of belts with resources being fed in towards it. Because this is a rocket that we're building here, you can put absolutely anything you want in it except liquids. So you'll see we've got various types of ingots, we've got some cryonite and vulcanite, but we've also got some pumps and some solar panels being fed in as well. You'll notice that I'm controlling the belts here instead of the inserters. This is because inserters that are loading a rocket should always be set to only run if there's a complete rocket in the silo, because you need to load the rocket parts in as well. So we configure the rocket part and rocket pod inserters. So we come along here, we set this one up to only load in if rocket parts is less than 100, and we set this one to only load if space capsules is less than 1. There we go. We can now see that it's loading up. It's got one space capsule in plus some spare ones that I need to get rid of. So put this iron in there and get rid of those. There we go. So these are being put in here, and they're immediately being added into the cargo rocket here. However, the reason you need to do this like this is because if you're not careful, you will end up with far too much stuff being put in here, and then no room for these rocket components, and therefore the rocket won't be able to be built. Over here, we can link all of the inserters in as well, and then program these to only load anything in if there is a rocket signal, and this means that a cargo rocket has been built, so only insert if that is greater than 0. And then we can copy that to all of them like so. And now that means these will only run if there is already a rocket built into in the system. I strongly recommend doing this, just in case you have some sort of interruption in your supply of rocket parts. We also need to program everything up, so let's come over here. This landing pad can be called, let's call this one Tutorio, like so. And then we can come over here to the rocket, so we need to set it to launch on cargo full, that's correct. We want to go to Norvis, because that's where this landing pad is. And then we say we want to go to Tutorio, and it shows you it in the list. There we go. So we've got the rocket ready now. It'll launch when it fills up, and it'll go to the landing pad we want. I now need to hook up all of these belts to the circuit network as well. So let's take another piece of red cable and link that onto there. Now all of these I've come in before already and set them up to say if there's fewer than 0 pumps showing on the circuit network, then let some through and they'll automatically be loaded in. So this works in exactly the same way as I showed you before with the delivery cannon. It's just able to carry far more things and far more different things because it's a rocket. So let's start by putting in a request. Let's come over here to the combinator over here, and we'll say that we want to have, let's say we want to have 100 copper plates. So we'll put in minus 100 here. That belt starts flowing, as you can see, and the inserter starts loading up the rocket. And here's the copper being put in as we expect. But now it's got to 100 and it's carried on going. This is because we haven't taken the plates inside the rocket into account. So what we need to do for this is also link up the rocket to the circuit network, or the rocket silo to the circuit network, like so. And now it knows about all of the stuff that's inside the rocket. If I mouse over here, you can see we've got those 4,200 iron plates and 166 copper plates. So we know about those. They've all gone into the silo. The system knows about them, so it stopped loading. And as you can see, the belt has stopped running. Now I can put in another request. Let's say we want to have some vulcanite as well. So we always want to have some vulcanite in space. We want 200 of vulcanite because we use it at a slightly higher rate, perhaps. So I set in that minus 200 over there, and we can see over here there's still request of minus 116, and then you can see that dropping as the rocket gets loaded up. And when that gets down to 0, we'll see that the system will automatically stop. And yes, there'll be a little bit of overflow because of what's on the belt, but when you're setting up a system like this, you generally don't care about exactly how much of the resource you have. As long as there's a decent supply of it available, that tends to be okay. You can set up as many different belts around the rocket silo as you want to load it up in this sort of system. And if you discover you're running out of space, then you can always have one belt running into it like that, with perhaps with a splitter feeding in, and then different resources being brought on in these different belts. Yes, again, because you've got all of this extra belt space, you'll end up with a bit more of each of those resources than you expect. But again, I don't think that really matters. If you have some other supplies you want to transport, but you don't have a full belt of those available on the bus, so things you're building in relatively small quantities, like locomotives or assembly machines or anything like that, for those you can summon using the logistics network. So we'll place down a blue requester chest here, and we'll put an inserter on it as well so it can unload. This will also need to be connected to the network, but we need to turn the negative requests that we're seeing on the network here back into positive numbers that this requester chest will understand. So to do that, we put in an arithmetic combinator here, like so, and then we link this up to the network on the input side, and then we link the output side to the chest, like that. We tell this to multiply absolutely everything, so the each signal, multiply that by -1, and output each once again. So we now see, if I put in another pylon and link that in as well, we'll see over here we've got, well, they're currently all positive numbers. Over here, they're all negative numbers. So if we look over here, if we say, actually we also want to have, let's say, yeah, let's have some locomotives. That seems like a good idea. So we want to have 10 locomotives. We can set that. And then we need to go into the requester chest, and we need to set the requests on it. So that means instead of reading what's in the box, it takes the signal on the circuit network and then it asks for those things. So we do that, and then there we go. The robots automatically bring in the locomotives and they load them into the train, and we've got slightly more than we asked for, but that's a running theme here. All of these things at this stage of the game, you don't care about the exact numbers of things you're getting. As long as you're getting enough, the rest can just go into storage for the next time you need them. Once the rocket finally fills up, which will take quite a long time because, as you can see, we've got the full 500 stacks available on here, but once it finally fills up, it'll launch because the cargo's full, and it'll take everything over to the landing pad that you told it to go to. So, nice and simple. As there is a slight downside to this system, which I should probably mention, and that's that when the rocket is in transit, it will no longer be reading the contents of the rocket silo out into the network. So that means that quite a lot of the things that you're requesting, you'll get a little bit more of that coming through. But that just means your second rocket, will have a bit of the sort of things you typically get through available for it. So I don't see this as a serious problem. It just means you'll end up with slightly more of the things you want and you need. But eventually you'll find everything settles down to a sort of equilibrium. At the other end, you will need to unload this landing pad so that the next rocket can turn up. And a good way to do that is to unload it into a warehouse, typically with a load of stack inserters like that. But one thing to be very aware of is making sure that you have also linked any additional storage space into the circuit network as well, like this. If you don't do that, then the rocket will land, everything will be unloaded into here, and then it'll be forgotten about. So you'll get another rocket out with all of the same resources, and you don't want that. You always want to have all of these things linked together like this. So any storage space you have in your outpost should always all be linked together, so you know what's there and what you need to request. My favourite part about the system is that when you're working on your space station and you realise you need some supplies, you can just come over and add them to the shopping list. So I say, actually, I need some stack inserters, and then they'll automatically be brought over, put into the rocket, and they'll turn up on the next rocket that shows up. The only downside of this is it can sometimes take a while until the rocket fills up and is ready to fly over. You can sort of short circuit that by hitting the launch button on here, but then as you can see, you start to get, as I was saying earlier, you get these additional resources coming over. so you do get a little bit more of the things you weren't really expecting. There's a bit of a delay while the next rocket is constructed from all the parts that are being passed in over here, and actually this one should also have these rules set on it and be linked in like so. So that gives you a little bit of slack time. But then now, as you can see, the rocket has landed over here. Everything's being loaded over into this chest, and once it's finished unloading, we'll be ready for another rocket to come out. You can use exactly the same system to load a spaceship as I've done in my actual main playthrough over here. We've got the same sort of belt feeding in here from all of the different belts that are wired in together, and the blue chest that's wired in up there. All of this then gets fed down this long belt and into the spaceship. So I've got exactly the same system, but it is a bit more complicated working out how to tell a spaceship to leave when it fills up, since you can't just ask the warehouse in it to whether it's full or not. I did go over that in a bit more detail last week though, so check out that video, and if you've still got any questions, well, leave them in the comments or come along to my stream on Wednesday to ask them live. Thanks for watching, I'll see you next time.